Hi, everybody. Hope everyone enjoyed your lunch. I did ask for the big room, to be fair, but this is what they gave me instead. So my name is Brian Wagner, as you can see. I am a compliance specialist here to talk to you about enterprise security, which, depending on where you come from or your experience with either of those topics, might sound contradictory. But I'll have you know I've just recently joined this job role, and before that I was a security consultant with Amazon AWS Professional Services, and before that a solutions architect in the security space before that. So I've been working at AWS about 5 years, all within EMEA. Started in Germany, been over here in London for the last few years. But I guess why I'm saying that is I've seen a lot of enterprises both try to do security and also succeed at security. So I wanted to talk to you today about how to think about security as an enterprise perspective. Security is really, it's not really a technology problem. If you do enough due diligence, you do the deep dives into AWS, how AWS thinks about security, or the tools that we have, which we'll go over a few of those today, you realize that the tech actually is pretty compelling. But when we talk about enterprise security, that's when it's a mindset change. You know, we're here at Transformation Day. This is not Security Day. This is not Automation Day. This is Transformation Day. This is how to transform the way you think about IT, or in this case, the way you think about security. So then and now. So on the left side of the screen behind me, you'll see like clipboard, Excel sheets. I mean, I imagine this is relatively familiar to a lot of you in here. I go to customers today that it's basically spreadsheet driven, which isn't bad. It's just it was a mechanism that used to work, or a mechanism that still currently works. But it won't scale. You know, we talk about cloud, we talk about scale. That means more than just how many servers you have, or in our case, instances. Scale goes way beyond the tech, and it goes to the way you think about something and how you approach a problem, or in this case, security. So the now, on the right side where that arrow is, that's meant to represent code. Like security becomes part of the application now, just like the infrastructure, and just like the network. It's all built in, it's all baked into the application itself. So security is less about talking, and it's more about doing or enforcing. Three primary facets of any application in the cloud really is scale, cost, and reliability. You know, again, I mentioned scale already. Great, we know we can write a script that patches a machine. We've updated the security patches, or we've installed some new software. Well, how do you do that times 1,000 or 10,000 or 100,000? How do you manage access to all those devices if you are indeed going to be patching? That's what we think about when we think about scale. That's just one example. Cost. How much is that going to cost you? How much does security cost you? How much should it cost you? Unless your business is security, security, like IT, is a cost, right? Unless, like I say, unless you're a security company, then that's not your product. How do we achieve a greater level of security and minimizing at the same time minimize cost? And reliability, repeatability, how can we replicate this at scale? How can we do this for our environment here locally today, where I sit and I can see it? And how do we, at the same time, trust someone half a world away, that's 12 time zones away, that I know that when they start their application, just like I start mine, that our business is safe, that we've done the right things? So we have tools. We have lots and lots of tools. This isn't even all the tools. And I'm not here to go through every single individual tool that we have, but these tools are definitely very applicable to the security story. For anyone here who's relatively new to AWS, this can be daunting, but don't let it be daunting. There are a few of these services that are super, super easy, that will instantly enhance your security posture the moment you turn it on. I think a good example here is Amazon Guard Duty. Has anyone here actually used Guard Duty or heard of Guard? Oh, we've got people using it. Excellent. So Guard Duty is this really great, simple, one-click, turn-it-on service that looks after your account, your AWS account. And what that really means is it looks at telemetry and data happening on the infrastructure side. There's no agents or anything like that. It basically uses all these different sources of information that are being generated from your account. And it can tell you really interesting things from a security space. You can do things like, it'll tell you things like someone's Bitcoin mining in your account in a different region that maybe you didn't know about. Or someone's trying to brute force your database. They might not have been successful, but wouldn't it be interesting to know about it so you know how to deal with it later? And I also want that example about the database brute forcing. And if you're not from a security background, you might think that someone brute forcing your database and not being able to get entry to it is innocuous. but actually it's actually still a threat. That means someone knows where you are and someone has some idea of how you run your infrastructure, and that could open up to other threats. So that's a great example of working backwards. When we talk about security at scale, we talk about enterprise-grade security. Instead of saying, well, I need to make sure antivirus is installed, I need to make sure we have span ports enabled for weird networking stuff, take it the other way around. Take your business, take what's important to your business, or even individual lines of business, whatever the case may be, and start expressing in plain English what it is you need to achieve from a security perspective, and that will give way to which technologies, which security services you end up using from Amazon. It makes the process a lot less daunting, because once you, like I said, once you kind of unpack what AWS offers in the security space, there's a lot of options, and each of these things have very different purposes. Another example, I gave GuardDuty as one, Cloud Trail. Cloud Trail is a service. Is it security? Yeah, I guess it's all security. Cloud Trail is a service that logs every single API call in your account. Now, for those of you who are brand new to AWS, everything you do on AWS, and I do mean absolutely everything you do on AWS, involves an API call. Do you want to create a new machine? API call. Do you want to just describe that machine, describe the properties of that machine? That's an API call as well. Create a database table, create a whole database, create an entire network, create an entire infrastructure. All of that is API calls. So, and every single API call has to be signed. To sign an API call, you need credentials. So I'm kind of working backwards here. What Cloud Trail offers you as a customer is the ability to see every single API call run against your account. That's one of those services that you just turn on. You say, I would like to see what's going on in my account. You turn on Cloud Trail. For my customers that I personally help, this is one of those services that should be on by default, and it should never be turned off. Because no matter what happens in an account, good or bad, you'll always have an absolute record of everything that went on, because everything's an API call. Down to the network changes, everything API. So customers can use that to develop all sorts of insights. In fact, we have some great partners in the partner space, like AlertLogic and Splunk and Datadog, for example, that take these Cloud Trail feeds and can give you some really interesting information on it. So Cloud Trail for us, as you can see here on the right side of your screen, it's a place where data lives, right? From a Cloud Trail perspective, that's all there is. And I'm putting it in air quotes because there's tons of other services that you saw in my previous slide. I'll go back for a second, that can consume Cloud Trail. Cloud Trail ends up being a data feed. Cloud Trail is a structured JSON, but it makes it really great to ingest into whatever your incident response platforms are, or your forensics platforms, to see what's happening in your account, and maybe someone changed some network posture that allowed them external access. You can trace all of that through Cloud Trail, one of those fundamental services. Now, on the other side of that is another service that we call config and config rules. Config does do some similar things to Cloud Trail, but Cloud Trail, big difference here is Cloud Trail is individual API calls without context. Just one call after another, time-stamped, whatever IP address it came from, time of day, what services they were trying to interact with, what the API call was, things of that nature. Config takes that and puts it in context. Config will say, all right, someone went in and changed all the stuff about the networking architecture. Someone added an internet gateway, someone opened up a firewall, and basically exposed a resource to the public. So you might be able to use config to kind of look after the holistic changes in an environment, and config rules, which hopefully are sort of logically make sense, to say, well, is that change okay? When we talk about cloud, and hopefully you've seen it in other sessions, when you're putting your business, you're putting your applications into the cloud, everything becomes much more fluid. Things are changing all the time. And to really succeed when you're moving into cloud from security or otherwise, it's important not to apply a one-size-fits-all concept. So for example, if you have workloads that are running PII, or personally identifiable information, well, that should have a different security posture than something that's completely innocuous and internal, or even completely innocuous and external, for example, maybe like a public-facing website. You don't have to treat them the exact same way if you don't want to. And things like config and Cloud Trail and a number of other services, you can use in conjunction or with each other to achieve whatever level of security that you need to achieve for that particular application. And that's what we talk about scalability and repeatability. Cloud at scale, security at scale. Think of the business objectives, and in this case, the security objectives of every single application that you're launching into the cloud, or every system if you're not application-based. if you consider those every single time, you can start working backwards based on the needs. Okay, this workload is processing payments, so one of the requirements is that it's PCI. It has to be PCI certified. So what are all the things that I as a customer need to do to become PCI certified when operating this in the cloud? That would look very, very different than, say, well, this is my sort of my front-facing brochure informational website. Very different security needs. Cloudwatch Events. So we're talking about the tech, and I want to bring it home to how the tech applies to use the customer and when you would use things like config and Cloud Trail all the time, config when you want to look at configuration drift. Cloudwatch Events introduces an event-driven security model. So if you're in the security space, you might be familiar with the different control domains. So you've got directive, preventative, reactive, detective and then reactive. Yes, those are the four. That's what I was thinking of. Traditionally is very much focused on preventative. Don't ever be allowed to do anything at all because that anything might be bad. So you can only do 4 things. You have 4 buttons in front of you. You can just mash buttons. That's your environment. And you have to shoehorn everything into that environment. But that is generally based on the restrictive ability to kind of launch things on-prem, or you have an on-prem environment that is homogeneous, and you can't apply different security postures to different workloads. Where in the cloud, you can just spin environments up as you need to, and you can still keep those what we call guardrails in place. So Cloudwatch Events is a heavy focus on the reactive, or detective and reactive for that matter. So as I mentioned before, I'm kind of building this up. Cloud Trail is that service that is every single API call. Cloudwatch Events can actually subscribe to that Cloud Trail feed in real time. And it will emit events that you might find interesting. Interesting good or interesting bad, that's up to you. But it gives you the power to say, well, none of my applications should ever have internet connectivity. So I guess if anyone who's new to AWS, I should unpack that a little bit. You're assuming, or you may assume, that by using AWS, you're automatically on the internet. That's actually false, right? When you create a VPC, or a virtual private cloud, which is your own network space, by default, it has no outbound connectivity. It is only a private IP address space, and nothing that you create inside of it has public-facing resources or public-facing IP. There's not routable to the public internet. So you might have a business case that says this application should not have internet access. Right? As I said before, that's a statement you want to make, and we can talk about what it means to work towards that goal. How do we do that? Well, first, as everything is an API call, I mentioned that before, internet access, or granting internet access, is through an API call that attaches what's called an internet gateway. Without an internet gateway, you can even assign public IP addresses if you want. Without an internet gateway, there is no route to the internet. So if you have a rule that says, I don't want an internet gateway in my VPC, well, you can code that up in a number of ways. And this isn't, I'm going to talk about that in a governance talk after this at a different room. So I'm not going to get into everything leading up to that. You can write preventative controls that say, well, simply deny that action for anyone to create an internet gateway. That does solve your problem, does it not? If no one even has permissions to create an internet gateway, well, you shouldn't have internet gateways cropping up. Well, some of you come from very large organizations, globally distributed organizations that have central IT services or central security services that run all these sort of guardrails and rules for you. Or you're sitting here and you are those people that are running the rules and guardrails for your internal customers. So how do you make sure that someone half a world away, let's call it Singapore for right now, how do you know that someone on the development and the business side is not, they've created an account through organizations, so there's multiple account model, for example. How do we know that they're not going to be able to create an internet gateway? Or how do we know, a better question, which brings us much more, hopefully, closer to home. How do we know that they've never created an internet gateway? Right? Think about that. It's easy to say, yeah, it's preventative. That's fine. But if you get audited internally or externally, or you have a new CISO, for example, that says, well, show me that it's never been a problem. That means, has data ever been exfilled through this particular method? In comes these detective controls in the form of Cloudwatch Events. So as I said before, Cloudwatch Events can subscribe to a feed of API calls. Well, if one of those API calls is create internet gateway or attach internet gateway, you can ask Cloudwatch Events to subscribe to that. And it is up to you, the customer, to decide what to do with that information. Very simply, you can notify if you want. That's what over here in targets. You can simply send something to your phone, to your email, to a SIM if it's API driven. But what is super cool is you can actually, that top right in the cloud on the right is a Lambda function. You can actually execute code against that thing that just happened. So if someone manages somehow to get through your preventative controls and says, I'm going to create an internet gateway, well, Cloudwatch Events can pick that up and say, well, sorry, you can't do that actually. And it can terminate that internet gateway immediately before it becomes effective. This is a very important concept. I spent a lot of time on this slide intentionally. In the spirit of Transformation Day, that is a major difference than saying no one should ever create an internet gateway. Well, if you're central IT or your central security services, I mean, do you know that across the board that no workload will ever have internet connectivity or never need it? Maybe not. What if you're opening a new line of business and you're trying to sell data on a data platform? You need APIs, for example. Those are going to be accessible from the public internet. What I'm saying is if you think about, if you rethink the way you're doing enterprise security and you actually delegate more responsibility to these teams that are responsible for their applications, you build it, you run it, you secure it kind of thing, you'll actually find that security becomes the reason that a lot of customers move to cloud. In fact, in the financial services world, which I'm mostly exclusively aligned to these days, that's exactly what is happening. The banks, I've worked with banks that are hundreds of years old, literally hundreds of years old, that say, why on earth would we go cloud? And if you can actually lay out the security story for them and say, actually, it's going to be safer in the cloud. And a lot of banks fully subscribe to that model, and they say, wow, now actually the security becomes the reason I move to the cloud. Forget the cost, forget the scalability. Those are all beneficial as well. But if you're telling me I can actually be safer and have more visibility over my environment in the cloud, I'm all for it. So Cloudwatch Events, a little quick summary. Driven by API activity, only on read writes, so they don't do things like list. So that might be interesting, or like list, get, or describe. Those are calls that might be interesting from a, I wonder who's looking at me, who's like a reconnaissance mission. I just want to list and I just want to do gets. That guard duty service will kind of augment that. So if now we're starting to kind of piece things together. Another benefit of guard duty, if I can sort of jump back for a little bit, is it does user analytics behavior. So I would call list, get, and describe part of that space to say, well, it's harmless, right? Someone's just enumerating your resources. But why would someone enumerate your resources if they didn't have a need to, or it came from an IP address that you don't recognize? Well, they're probably doing it for reconnaissance sake. Surely we've all seen the movies where, in the spy movies, where they say, well, they have to case the joint first, right? Or criminal movies. It's the same on the internet. If you've ever put a host out on the internet, doesn't matter if it's AWS or not, and put a public IP address on it, sure enough, you're going to end up in a database within 60 seconds. It's just automation. Everything's just there. So you still want to look after that, which is what that service guard duty, one of the features is user analytics behavior. It'll actually baseline the account for normal activity. It takes about 45 days-ish, 30 to 45 days to understand normal. And it will then start alerting you on, well, for the last N days, this has been normal pattern, but now someone from a country that you don't do business in is suddenly trying to do list, get, and describe on some of your resources. That could be a problem. Someone could be watching you. We're going to go through every single one of these. No, Cloudwatch Events doesn't support 100% of API calls. So if you're sitting here thinking, wow, this is the solution to all my problems, and someone actually has come up to me after one of these before and said, this is literally the solution to all my problems, there are a couple of caveats I want you to be aware of. I'm not going to name every single service, but there are most of the services, most of the mostly consumed services are in here, and you can subscribe to these sort of events that are interesting. Now, this is the best. This is the best part. If you're here and you're not responsible for infrastructure as code or a configuration drift or security at the infrastructure level, and you say, I'm one of those application owners that you're talking about, or even in the application team that I'm talking about, how do I use this? How do I, my shared services team doesn't understand the specific needs of my application. Well, that's okay. That's why we talk about this stuff, or I talk about this stuff, in a way that I'm trying to get customers to delegate the authority of security that basically says, here's your box, stay in your box, nothing crazy outside this box, but if you're within that box, do what you have to do in order to launch your application to whatever the business importance of your application is. I'm just a security guy. I don't know what that means, but I want to make sure you do it safely. Cloudwatch Events are not just API driven. So that Cloud Trail is only one source of feed for Cloudwatch Events. You can actually build in your own events based on business logic. So you can emit events from within your own applications or infrastructure as you see fit in order to trigger a Cloudwatch event. Now, before, as I mentioned, that can have a number of user-defined downstream mechanisms. You could report it out. You could put it into your security incident management system. You can do both of those things. You can take remedial action if you want. A really simple one that I like to do at reInvent, our conference in Las Vegas in a couple of weeks, is put one of these events in for Cloud Trail. Right? We've already talked about Cloud Trail. We talked about Cloudwatch Events. You put the two together and say, Cloud Trail is such a fundamental service that it gives you this history of every API call. I never want it to turn off, ever. I don't care who you are and what part of the world, but if you're in my, if you work for the same company I work for, and I'm the security guy, my rule is Cloud Trail should always be on in every single account that we own, full stop. Very simple, very binary decision. I don't have to think about it. If someone turns it off, you don't have to wake somebody up in the middle of the night. You just simply turn it back on. That's exactly what Cloudwatch Events will do. You can tell it to look for the action, the API call that says Cloud Trail off. And if you see that, you can call a function that says just turn it back on. You do want to be notified. You should get that email in your inbox because why did they turn it off? You're going to have to dive deeper. You're going to have to investigate. But the point is, making those simple declarations, Cloud Trail should never be turned off. You can turn that into actionable code. And of course, it can get more complex than that, which is why I'm kind of introducing this. You've got your infrastructure rules, and you can even have your business-specific rules. So on the subject of security automation, we have a service called Systems Manager. So another major, I don't want to call it legacy because that's not fair. Another component of security in the enterprise is how to keep your estate up to date at all times. If you're a heavy EC2 user, our instance model, our instance terminology, how do you keep a dynamic environment up to date at all times? I mean, hopefully, if anyone who's anyone, whether you're a security professional or not, understands the importance of patching and the latest security patches. Vendors don't release those arbitrarily. They release them because there's a vulnerability, and then there's a patch to manage that vulnerability. So staying up to date with your systems is of utmost importance. So I get a lot of questions around, well, how do I maintain that at scale? How do you know that what version that this thing is running? If there's a business over here, they're starting up instances, they're running a job, and then they're shutting them down, and they're not there anymore. How do we know they weren't woken up from a version from a year ago? How do we know that that's patched? How do you manage that at scale and dynamically? I mean, we know how to manage it in a data center because the resources are finite. They're always there. You know exactly how to get to them. You might have bastion hosts and keys and all that sort of thing. Well, we've tried to help customers solve that problem with the service that we call Systems Manager. And Systems Manager is actually a compilation of several services. I'll pick out a few of them. One of them, State Manager or even Patch Manager. Those are similar. But you can actually use this service to do exactly what I just said, to say, well, look, I'm cool with Python, but as long as these libraries are installed, or OpenSSL, I guarantee there's someone in this room that has a data center with Heartbleed still in it. Heartbleed was what, 2014? Guaranteed. Someone here has Heartbleed on a server somewhere due to an outdated version of OpenSSL. Just fact. That's not a bad thing. It's because these problems are very hard to solve. So AWS has tried to help you solve them by creating this service which does all this stuff at scale. When you're actually consuming these services, instead of saying, well, this host and this host and this one as well, and it has to have this IP address and these properties, you actually base it on tags. So in AWS, most of our resource types have a concept of tags. I'm going to start this instance and this database and this load balancer, and they're all going to have a tag with its key value pairs. There's up to 50 per resource. This tag is environment equals production or dev or whatever. And you can have multiple tags. When you're running these services, your target is not an individual machine or an individual instance. It's actually tags. So if you're tagging accordingly, well, you can use these services just to say, look, do recon on every one of my existing running EC2 fleet across the board, and return all the versions of all the software on every single machine. Windows, all the flavors of Linux, in a completely disparate environment. No problem. It'll roll them up and normalize them and say, here's your report, and there's this many in scope, or sorry, this many of this version, this many of that version. And you can roll out Patch Manager to go and update that and say, okay, good, just these ones need this much work, these ones need that much work, and you can schedule it and roll it and everything like that, rolling as far as like downtime if you don't take everything offline. But it becomes a single point of operations instead of having to go to every single one. Another great example is run command, probably one of my favorites. Run command is a scripted, and we'll see it here in a session. Actually, I think it's the next one. Is it not? No, sorry, it's not. But anyway, run command is a scripted execution engine that will effectively replace the need for interactive sessions. So interactive sessions meaning RDP for Windows or SSH for Linux. That's pretty powerful, because how do we patch in the past? Is we probably log in and we patch them, or you run some script individually, but you still have to target it. Well, even that is not terribly hard. Some of you in here are scripters, you're coders. You can get a script that kind of enumerates your stuff. But you know what's really hard is managing access to all of those, not just from a networking perspective, but if you're doing, let's say you're doing key-based access, public-private key sets. Well, where do you store all those keys? How do you manage those keys? Where are those kept? How do you protect against those? How do you rotate those? What about passwords? You're going to enable long-term password credentials to your devices. That sounds dangerous, especially ones that are coming up and down as needed. Surely then they're all sharing credentials. That's also bad. So run command operates the same way as I mentioned before. Just give it a target and say anything that matches these criteria, go run this command. And that could be particularly useful for incident response or forensics or patching or any sort of business logic. You can use it to deploy software. You can use it to update configurations. But what's really cool is how I said earlier that every single action on AWS is an API call, and every API call has to be signed, and the way you sign it is with credentials. That's true of run command as well. What if you could know every single command ever run on a machine with their log output, by the way, and you know for a fact who did it and when and from where? Because all that API stuff from run command, when you do run command, that's an API call, goes to Cloud Trail, and Cloud Trail is your source of record. You get unmatched visibility, and that's just one example. I'm not going to go through the others. You get unmatched visibility of what's happening in your environment at scale. So it becomes this one-stop shop. And that's really the goal of enterprise-level security, is giving your teams the necessary freedoms to do what they have to do, at the same time looking after what's important to you. So role-based access control is extremely important, an important concept of the systems manager slide that I had mentioned before. It gives you a way, like I said, at scale to manage access to these instances. We've actually introduced a new service that does just that. So you don't have to deal with managing public-private keys. You don't have to deal with managing passwords. In fact, if you go to any search engine, DuckDuckGo, for example, my search engine of choice, if you look up AWS best practices, security best practices rather, it's more in the context of our identity service, but generally speaking, no long-term credentials. Long-term credentials are dangerous. Long-term credentials are what you see, are the result of what you see in the news when this big company, that big company lost all their data or someone stole all their data. It's all, time and time again, it's, these credentials from someone that was no longer an employee as of 60 days ago were leaked, and someone gained access to those. So if we take away, so the most important thing in this slide, by the way, is role-based access. All of these systems manager services that I told you about, which have potentially impactful results. You have direct access to machines. You can install things on them. All of this is role-based access. That means the credentials are temporary at the time of execution. So if those were somehow leaked or compromised, or you communicated with a server on the internet or whatever, those credentials are meaningless beyond that single call. So patch management, I did mention that as well. If you think about it, in a homogeneous environment, Windows or Linux or whatever, and all the different flavors of Linux, some of the fundamentals, the primitives are true, right? You want this version of OpenSSL. You want this version of Python. There are some very simple, common concepts across the platforms that might look a little bit different in the output, but we have a patch manager that sort of normalizes that. You can actually say, well, I have Windows hosts and I have these different flavors of Linux, and it knows where to find that. Is it a yum, is it a yum update, or is it an apt-get update, or is it Windows? It knows how to do all that. You just tell it the important stuff. Everything should be Python 2.7. Like that's what you want, and then it will figure out the rest. It makes that, it gives you that ability to, like I say, delegate. So if someone wants to run Python 2.7 on this environment, and someone wants to run Python 3.6 over here, and one's Windows and one's Linux, this doesn't care about any of that other than to make sure it deploys the right or asks the right questions for the right system. But it takes all those problems and puts them And it makes them simpler. You can actually automate it from the center. And that's why, like I say, it gives you that ability to delegate. This is a very poorly visual example of run command that I was mentioning before. But this is that arbitrary stuff. So these two things are not arbitrary. These are like, I want a patch, and I want this software version to be that software version. It's pretty specific. This run command could be a complete replacement for SSH, for interactive sessions. So if anyone in here does incident response, you might find that impossible. You might say, well, maybe 4 people installing stuff, but not me. I need incident response. But I say, actually, no. What do you do on incident response that you need interactive sessions for? Well, you need logs. You need memory dumps if you must, if you're a forensic, if you need to gather it for forensics. There's a couple of operations that you can do on the system that can be scripted ahead of time. What's cool about run command, it's just JSON, right? Everything's just JSON. Jason's a very popular guy. I never met him. That's a bad joke. But what you can do with run command is create your own documents. And in those documents, you can put parameters in them. So again, central IT saying, look, if you want to do these things, here's the template for it, and now you get to inject your own whatever. Some specific version of business software, you can do that if you have to, I don't know, zip it up or archive it or whatever, and say, look, I don't know, I'm a central services guy. I don't know what the application team is doing. I don't need to know. All I know is that here's your box. I'm going to put you in this box, and I'm just providing you the empty box. You, as the application team, need to put stuff in it. So that's what you can do with these services, and more so run command than anything else, because it is templated, and you can version control it and everything. So this one is pretty cool. Updating software inventory. So this is a great way just to get a lay of the land, right? One thing that customers have always said was so difficult with AWS is exactly this. How do I know what I have out there? What is my asset management, like software asset management solution? How do I know how many licenses of things I have? How do I know how many copies of whatever do I have? This is important stuff at the enterprise level especially. And the way to control that information historically is to be a gateway. And you say, oh, you need this particular software. Well, you have to come through this, it's a solution, and then it's got to be approved by this person and that person. And I'm not saying you have to just let everybody do whatever they want, but you can actually go out and start figuring out what versions of software everybody's running and take a pretty holistic inventory at a point in time of what software you've got running across your entire estate. Another one is managing configuration drift. This is a really great supplement to, if you remember some slides ago, I was at kind of the macro level with config and saying, this is your AWS estate. This is the state of the network. This is the state of the, the S3 storage system. This is right down to the instance itself. You might need an EC2 instance that's configured in a very specific way. And if it's not configured in that specific way, you might be subject to penalty or something like that. PCI is a great example if anyone's in processing payments. Or you're hardening a particular instance because it's internet facing by choice. So if you have requirements for software or for an instance to be in a certain configuration, this is your best friend. So you'll always be able to know what state that exact instance or that fleet of instances is in. And you can say confidently, you can answer a question that I proposed earlier, which is, I understand that it's in a state now, but has it always been? That is something that most people cannot answer before AWS. Now, this one particularly powerful. Back to that long-term credentials kind of rant earlier. We should never have long-term credentials. It's a security hazard. It's a risk, just across the board, especially in the cloud, because the environments are intended to be more delegated. So how do you tell someone who has no idea why that's bad that you should never use long-term credentials, and then put the burden on that person or that team to come up with a solution to get rid of long-term credentials? The most obvious use case here should be databases, relational databases. What do you have to do? You have to log in, and you have to create users for everybody and passwords for everybody. If that's not long-term credentials, that's the most fundamental. It's been around for many, many years. So now this concept is not new to AWS, but we have secrets, arbitrary secrets is kind of an industry term. Well, these secrets are credentials. They're generally credentials. They could be a lot of different things, but in this example, to make it easy, it's credentials to a database. This is a secret that you want stored securely somewhere, safely and protected, and you don't want people to be able to use those arbitrarily. So now we have this concept of secrets manager, which in this case is an API call to do runtime, real-time injection of that username and password, in this case of the database, from an API call just before you connect. and then it will do the rotation as necessary. We even have another service that does the rotation on the database side as well. That means every time you use it, you could potentially change the username and password in the database itself. But it abstracts that management from the database, and it gives it to you in, that's right, an API call. API calls can be traced back to Cloud Trail, which is why I started this discussion with Cloud Trail. That means you as an administrator will be able to know every time someone, successfully or not, use that secret to connect to a database or whatever you're using the secrets for. Now, on the front side of things, which I'm not going to go into too much detail on, that's going to be in my next session in room 5, track 5 after this. We've been talking about detective and reactive, mostly detective controls. What about the front two? What about the first two? What about directive and preventative? A lot of that will come out in the way you release software. Or in this case, you release entire applications inclusive of the infrastructure. So we have a concept called, or we have a service called CloudFormation, and that is a JSON, again, very popular, or YAML depiction of what you want your environment to be. And it is, again, it is structured, and it is, it actually goes through a linting process. So if you have a comma out of place, it'll tell you. But what's important about that, and what you do is you submit that template to AWS. AWS makes it so. You define your network, your databases, your Lambda functions, your instances, everything you need, and then in a document, and you say go. And it will go and make that thing a thing. In the context of enterprise security, that is the mechanism we often recommend. If you want to start delegating security responsibility out to your application teams, which is what I am proposing, if you have them do it through a controlled method like this, well, it's structured. And you can actually apply static code analysis to it and say, hey, remember there's a rule that I said no internet gateways? Well, if you can actually really plainly detect, you can actually go structured document and say, are there any keys of this kind that are called internet gateway? If so, I'm sorry, I won't even let you launch that stack, let alone get to the point where we're detecting it and remediating it. Right? So this is kind of that full circle of enterprise security. Some other services, and by the way, I'm not even halfway through the slides, and I have 8.5 minutes left. I did touch on guard duty really quick, so I'm going to kind of glaze over some of this stuff. Guard duty is very, very helpful. It's one of those, if you had to walk away with nothing else today, if you only remember 2 things, turn on Cloud Trail in your accounts, turn on guard duty. They aren't free, but when you find the cost model, you'll find that they're extremely inexpensive. We're talking like less than $1 a month. They're not free, but they will give you 90% of what you need to know about your environment today. The whole point of Transformation Day, and even this talk, and I've talked to some of you out here now at the booth earlier, this is kind of a nirvana, like full automation. Wow, that's great, that's awesome. But what are the things you need to do to get there? You can't measure improvement until you take inventory. And Cloud Trail and guard duty are the ways, in my opinion, to get inventory. You can just, if you do nothing else, no reactive controls, nothing preventative, just turn them on and see what comes out of it. You'll be amazed. So a couple of ideas around security automation. DevSecOps. Some people like it, the term, some people don't. But I think the most important takeaway from DevSecOps is, well, DevOps previously, before we had DevSecOps. DevOps is you build it, you run it, right? DevSecOps is you build it, you run it, and you secure it. And the most important concept of DevSecOps, which is also the most important concept of DevOps, is the feedback loop. It's not one way. You don't just punt to application teams, or you don't just punt to security anymore. You need that feedback. I have a customer that with a very decentralized development model, they actually offer, their central security services offer their own people as consultants. So you say, I want an application, I want it in the cloud. You are assigned a consultant internally that will help you kind of build these kind of things and sort of evangelize best practices created within. But ultimately, delegating that responsibility out. Now that feedback loop, it's important to communicate that with developers. Again, you're going to get people who don't have security backgrounds not understanding why it's not a good idea to open up this instance to the entire world. They don't know. They just say, well, I need to communicate, so I need to open it up. It's just easy. You say, yes, but we need to make sure that we have policy of least privilege to only open it up to those services or other entities that need it. You're able to do this with that DevSecOps, that loop, to say, I'm going to check in this code. I'm going to execute this change on the platform on AWS, and it got rejected, but you got to tell me why. So it's this feedback loop. It'll drive behavior. So delegating authority is not scary when you have that feedback loop. Static analysis, dynamic analysis. Which should we do? Yes, you should do both. Static analysis, if you're templating, your CloudFormation, or Terraform's another one if you're using sort of a third-party solution. They're structured languages that you can actually filter out a lot of this noise in the beginning. If I'm putting something, as I said before, with an internet gateway on, we should be able to detect it right away and say, nope, sorry, pump the brakes, can't even do it. Secondarily, downstream, you say, well, the configuration looks fine, but how do they interact with each other? Static analysis is sort of point in time. It'll just find one thing and not really relate it to another, unless you have some very clever static analysis software. But dynamic analysis, the whole point of templating these things is to be able to repeat them. I can stand it up, whatever I'm doing, past my static analysis, stand it up in a controlled environment, and I can run dynamic checks. Maybe I run port scans or Qualys or antivirus, whatever it is. When you're satisfied with those checks, shut it down, and the mechanism becomes that DevSecOps pipeline. Because then you as a business can say, or even as a security team, and say, look, this application team way over there, they put their code through my process and everything looks good. And the control, in this case, the control mechanism is that that team can only deploy via that CloudFormation template. It's been through static and dynamic analysis, and we know for a fact that it hasn't changed on its way out. That's just some ways to achieve sort of preventative security. I've explained most of these concepts already, so I'm not necessarily going to step all the way through them. If you want to talk about DevSecOps, we can. But again, in the interest of time, I have to kind of speed it along. Focus on evidence. This is very important. If you're going to take away, like I said, I already told you the two things you should take away. But if you're going to take away additional things, it is to express the security objectives in plain English. We don't start with, OK, we need antivirus everywhere. Do you? Maybe not. What is the objective you're actually trying to achieve? Well, no viruses, yes, obviously. But if it gets more complex than that, we need visibility. We need to be able, we have a policy of least privilege. Good policy, I like that. But what does that really mean? You have to be able to express this in something that is evidenceable. How do you prove that to someone who's asking? How do you prove that it's always been that way? That's where our services come in. That's what we can help. Mapping evidence to specific controls. That's what this automation is. The output of all those automation tools, Cloud Trail, Config, Cloudwatch Events, all of those, and many more, the output is JSON. JSON can be consumed automatically and can be matched up to specific controls. You can actually say, this control means this. Go get me the result. And if the results match, well, then we've actually got a good, sound control environment. And enable your compliance team. I'm a compliance guy, but in your own compliance people, they're your friends. This is a very important slide. Again, as I'm running out of time, I'm going to speed through them. But I'm going to stop at this one just for a second if you're taking photos of it. This is a great way to understand or to kind of work backwards into developing a strategy. This is all about enterprise security. And enterprise security is not homogeneous. But the objectives are going to be very, very similar across the board. And some will be subsets of others. You might have, like I say, depending on let's say, your data classification, you might apply a full list of rules, whereas a lighter data classification might just be a subset. But that's important that you have a mechanism. The standard is not the controls themselves, but it's the framework in which you apply those controls. Output patterns, again, this is stuff I've already kind of covered, but I guess just like the environments themselves, there is no one size fits all. Do what is necessary that you feel is necessary as security professionals or security familiars. Whatever is necessary, do that. The technology is the easy part on AWS, and not easy as in everyone gets it right away. But there's 140 some odd services now in AWS. Surely there's a service that has some relationship to whatever it is you need out of the cloud. But it's really being able to take the ones that you need and apply them accordingly. Do you need to notify on this thing? Do you need to fix that thing? Does it have high judgment or low judgment? Is it severe or is it informational? Right? These are decisions that you're going to have to make and apply services and output patterns accordingly. So Netflix is particularly good at this. If anyone's ever gone to their GitHub, they have some pretty cool tools. But basically, they've nailed role-based access for their accounts, especially in the way of forensic investigation. That's kind of also one of those concepts that customers still need to do, but it looks completely different. You say, hey, Amazon, I want a memory dump. He's like, well, no, that doesn't work that way because we're on public infrastructure. We're on shared infrastructure now. How do you do that and only give you your piece of the memory? Like, we actually obfuscate the memory, right? Read our white papers. But you can do that, right? You can do, Netflix is very good at this. They can do what they call stealthy acquisition, to be able to pull all the information off of a compromised host without them knowing about it. And you can do this using the tools that I talked about, using the systems manager. That's a run command. How do we do a memory dump? Well, that's a command line thing, right? You can do that, again, at scale. And even so, as everything is an API call, you can hook up Cloudwatch Events. I've got some indicator of compromise, and that raises a Cloudwatch event. Event can trigger that run command, which does a memory dump, for example. It's this beautiful symphony of reactive controls. But that concept is what I'm trying to get you comfortable with, is that the reaction is not a bad thing. Before, it was this bad thing because generally the time to closure on an issue was so big. But now we're talking about by the time the email even hits your important inbox that something bad has happened or something maybe bad has happened, it's already been isolated or fixed, or the user who executed that nefarious command, their credentials have already been revoked. That's what you want to hear. So as I'm out of time, have a look at this. This is a great way. These are some of our customers that have created open source concepts or open source versions of some of the things we were talking about. All these little, I'll call them frameworks, or these toolkits, are based on the services I just told you about. So you can go to threatresponse.cloud. Very good friend of mine runs that, based in Oregon in the United States. He'll also be at reInvent if anyone's going to reInvent. He developed, on his own time, a great set of incident response tools that use a lot of the concepts that we have, and I'm helping him modernize that right now. But if you're thinking about these problems that are hard to solve, they are hard to solve. It's not because you're slow or not getting it. They are hard to solve. But thankfully, a lot of people that are not us, that are not AWS, it's easy for me to come tell you things are easy. But we have actual customers that say, we've created this, and now we're offering it up open source to you all. I'm out of time. I have about 15 minutes before my next session if anyone has any questions or you want to follow me to track 5. But it's been a pleasure talking to you all. Thanks.